Have you ever stopped to think about why your salad dressing separates, but your coffee doesn't? Or how milk just seems to be perfectly mixed all the time? Well, it's not magic, it's chemistry. And today, we're going to pull back the curtain on the science of mixtures, which is happening all around us, especially in the kitchen.
Okay, so let's jump right in with a classic puzzle. You take some dirt, mix it with water, and pretty soon all the mud settles to the bottom, right? But milk just stays milky. Why is that? The answer is all about the hidden world of mixtures. So let's get into it.
You know, the word mixture might sound like something you'd only hear in a science lab, but honestly, our world is built on them. I mean, the very air we're breathing right now, that's a mixture. The coffee that got you going this morning, that's a mixture too. They are literally everywhere.
So, to make sense of this, scientists have a really simple place to start. They basically classify all mixtures into two main families. And it really just boils down to one simple question. Is it all mixed up smoothly? Or is it, well, kind of lumpy?
And this image right here shows that difference perfectly. I mean, look at that. On the left, you've got a mixture that looks the same from top to bottom. And on the right, you've got one where you can totally see the different bits floating around. In science speak, we call these homogeneous and heterogeneous mixtures. First up, we've got the homogeneous mixtures. Just think about dissolving sugar in your tea. Once you stir it, you can't see the sugar anymore, right? And every single sip is just as sweet as the last. That's because it's got a uniform composition. It's perfectly blended. And then you've got the other team, the lumpy side of things. These are the heterogeneous mixtures. That classic oil and vinegar dressing is the perfect example. You can literally see the little blobs of oil floating in the vinegar. You gave it a good shake, but if you let it sit, boom, it separates back into layers.
Okay, so some mixtures are pretty easy to tell apart just by looking, but what about the tricky ones? The ones that look uniform, but are actually hiding a secret? Well, it turns out we can use a simple laser pointer to reveal their true identity. It's kind of like a secret decoder for chemistry.
And the experiment itself is super simple. We've got 3 beakers here, one with salt water, which we know is a true solution, one with chalk and water, which is obviously heterogeneous, and then there's our mystery guest, milk. We're just going to shine a laser through each one and see what happens. Now check this out, because what's really interesting here is what you don't see. When that laser passes through the salt water, the beam is totally invisible inside the liquid. Why? Well, because the dissolved salt particles are so incredibly tiny that they can't scatter the light. The light just zips right past them. Whoa, but look at this. In the chalk water, that laser beam is as clear as day. It's like a little red lightsaber cutting right through. The bigger chalk particles are bouncing that light all over the place, making the beam visible. This really cool effect is called the Tyndall effect, and it's our secret weapon here. And here it is, the big reveal. The laser is also visible in the milk. So that tells us that milk, unlike salt water, is packed with particles big enough to scatter light. But, and this is the key, unlike muddy water, they're so small they don't settle to the bottom. Milk is a special kind of mixture called a colloid. And just like that, mystery solved.